In this video for section 16.2, we're going to talk about how to fit a quadratic equation to a data set rather than a linear equation. So we have some data, which is an equipment company. They lease large construction equipment to contractors in the Southwest, and they are to perform all repairs and maintenance on the equipment. They've collected data on the repair costs for a crawler tractor leased to a company in Phoenix for the past 20 quarters, and they are interested in forecasting future repair costs for the tractor. So we have our data. This is in Blackboard as usual. So this is our spreadsheet, and notice that it has the year, the season, and then the quarter. And the quarterly column counts quarters starting with the fall 2011 quarter. And then it lists the repair costs as well. So what I'm going to do first is I'm going to create a time series plot for the data. So I'm going to go to Graph, scroll down to Time Series Plot, click Simple. Then I'm going to put the repair costs as my Y variable. Click on Time Scale and Stamp, and the stamp is going to be the quarter column. So here is my time series plot. And when I look at this, what I notice is that the repair costs were pretty flat, not increasing too much for a long time. And then in more recent times, we noticed this sharp upswing in the repair costs. So that's definitely something that the company wants to be aware of. So that's what my time series plot looks like. Now we're going to create a linear model for the data and record the coefficient of determination, or R squared. So we're going to do this by going to Stat, going to Regression, and then clicking on Fitted Line Plot. And then I'm going to put in my response variable that I want on the y-axis. That's going to be the repair cost. And again, my predictor is going to be the quarter. And you notice here that I have the ability to select the type of regression model. So we're going to start with linear first. So I'm going to make my linear model. I see my regression equation here. So you might need to put this into MyLab if you're doing a homework question. One thing to be careful of when you're doing this with MyLab, you've probably already figured this out, but whether there's a negative sign in front of the number, you need to make sure that you're typing in those negative signs as well. So I see I have an R squared value here of 82.14%. And then when I scroll down, I can see the graph of the data with the line laid over it. So when I look at this line, I can see that it sort of fits the data a little bit. It's a generally positive line. It kind of fits the points, but it maybe doesn't fit the points as well as a quadratic graph might. So I'm going to write down my R squared value here of 0.821. And then I'm going to switch to creating the quadratic model. So remember, in MyLab, you're going to need to convert this percentage for the R squared value into a decimal. So that would be 0.821. They want you to have 3 digits after the decimal point. So now I'm going to make my quadratic model. So I'm going to go to Stat again, Regression again, and Fitted Line Plot again. I have my variables in here correctly. All I need to do is switch to quadratic. So click on that to switch it, and then click OK, and it will make the quadratic model. So notice that I have my regression equation here. Remember from algebra that quadratic means that you have a x squared, or whatever your variable is, squared in your equation. So I still have my constant. I still have a number in front of the x, but now I have also a number in front of x squared. So again, here's the regression equation so that you have the numbers to put in the homework. I see my R squared value here is 94.66%. So that's a higher R squared value than I had with the linear equation. And I also see when I look at the graph with the quadratic equation laid over it that this quadratic fits the data much better than the linear equation. The points are much closer to the shape of this quadratic equation than they were to the line. So I'll go back to the line here so I can kind of look at them both. Points here are further away from the line than they are from the quadratic curve. So my R-squared value here, 94.7%, or 94.66. Again, that would round up to 94.7 or 0.947 for my R-squared value. And then which model fits the data better? The higher R-squared value fits the data better. So that's going to be the quadratic model.